Okay, first video in a long time where you're taking notes anyway, so remember that you're responsible for pausing, rewinding, rewatching, whatever it takes to get this right, and that you're also responsible for margins and summaries. Without margins and summaries, I'm giving you a 50 on your notes, so get it together. Alright. So we've talked about similar for a long time. You learned this in middle school. Just to recap, this is the symbol for similar. Just a little wavy line. Similar shape, have the same shape, but not necessarily the same size. So what you're looking for, what makes them have the same shape, is they are going to have congruent angles. And then not necessarily the same size, they're going to have proportional side lengths. Proportional side lengths. So same shape means that the angles are all congruent. Well, not all, but the corresponding angles are congruent. Same size means proportional side lengths. So here we have an example. These two angles are corresponding. They're going to be congruent. These two angles are going to be congruent. These two angles are going to be congruent. And then the sides are going to be proportional. If this is 3 and this is 6, and then if this is 2, this is 4, and on and on. Okay, these are not similar, 1 and 3, because their angles are not congruent. You can tell this angle here and this angle here are not equal, so they are not the same shape, so they are not similar. Alright, here we see that in a little more detail. Two polygons are similar if and only if their corresponding angles are congruent and their sides are proportional. So that's what we just discussed here. Now here is a similarity statement, which we will talk more about later. You saw the same thing with congruent statements, but just so you know, this polygon is similar to this polygon. Okay, angles are congruent, sides are all proportional. Alright, identify the pairs of congruent angles and the corresponding sides. So let's start with angles. Obviously, it's easy to tell that angle N is congruent to angle Q. Angle M is congruent to angle T, and angle P is congruent to angle R. Then we can go with sides. NP is proportional. We'll just list them like this. NP and QR are proportional. MN and QT are proportional, MP and RT. So super easy there, you're just going to list them out in order. Alright, a similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. Now, you have to be very careful with this. This is about the only place people mess up, but people messed up a lot on this last year. Whichever way you write the order of the polygons, you have to keep the order of the ratio. So here's my example over here. ABC has side lengths of 3. DEF has side lengths of 6. So if I say ABC to DEF, then I have to do 3 to 6, so the ratio is 1/2. I can flip that and say DEF is similar to ABC, but that means I have to flip the ratio, 6 to 3, because I said the 6 side first and then the 3. So whichever triangle or figure you talk about first, his side length or his ratio goes on top of the other one. If you switch this up, if I were to say DEF to ABC, and I were to say 1/2, that would be wrong, okay? Because it should be 2, 6 over 3, it should be 2, okay? So just don't do that, and that's the only place you can mess this up. Alright. Writing a similarity statement is the same as writing a congruent statement. You want to be sure to list the corresponding vertices in the same order. So what we're talking about here, let's go back to this example on the other page. If I wanted to write a similarity statement for this, if I wrote triangle MNP is similar, I have to make sure to do this in the right order. So if I said M first, then I have to say T first, because M and T are the ones that belong together. N came in the middle, so that means Q is in the middle over here. P came last, so that means R has to be last here. Because people are going to read this, and when they read your similarity statement, they're going to automatically know, okay, M and T, N and Q, P and R. M, N should be with T, Q, and on and on and on. So you have to make sure you write these in the correct order, or you're going to lose points for that. And you're not going to be saying what you want to be saying, and that's a bigger problem. Alright, so let's do some. You've done these kind of proportions since middle school, so the math shouldn't be hard. Just make sure you're taking the time and setting it up right. Determine whether the polygons are similar. If so, write a similarity ratio and a similarity statement. So let's compare. If I say 6 over 4, then that reduces to 3 over 2. And then let's compare. That would be 9 over 6 from this side. So that would reduce to 3 over 2. So I compared the short side from here with the short side from here, this long side from here with the long side from here, and I got the exact same ratio. So I would say, yes, these are similar. And then I could say rectangle ABCD is similar to rectangle EFGH, and the similarity ratio is 3/2. Okay, the only thing you don't want to do is you don't want to compare within the same side. I don't want to say 9 over 6 and 6 over 4. I have to compare this rectangle to this one to this one. I'm trying to see if the two polygons are similar to each other, nothing about the sides within the same figure. So just don't make that mistake and you can't mess up. Alright, same thing, determine if they're similar. Yes, write a similarity statement. Okay, why don't y'all pause here and try this one. Okay, so here we don't have all the information, so we're going to have to go and figure this out. So I use the triangle sum theorem, and I also noticed that this is an isosceles triangle. So I took out the 36 because the triangle sum, and I divided by 2, because if this is an isosceles triangle, then the isosceles triangle theorem says the base angles are congruent, which means the base angles have to be 72. So if you look over to this one, the base angles here are 62, so since the angles are not congruent, these cannot be similar. Okay. Find the length of the model to the nearest centimeter. So here, this is just a straight proportion that we're going to set at. Now remember, you can flip these proportions over, so yours might not look exactly like mine, but I'm going to say 1.8 over 6.3 is equal to 5 over x. If you wanted to say something like 1.8 over 5 is equal to 6.3 over x, you would get the same thing. As long as yours, when it's set up, 1.8 and x are across from each other, 6.3 and 5 are across from each other, then yours are okay. Okay, so then we just cross multiply. 1.8x is equal to, 6.3 times 5, 31.5. Divide by 1.8, x is equal to 17.5. Okay, then you can always go back and check to make sure you did this right by finding your ratio. 1.8 divided by 6.3, this has a ratio of 0.29. 5 divided by 17.5, this has a ratio of 0.29, so I know I solved the problem correctly because the similarity ratio stays the same. Okay, y'all flip over and try 3B on your own. Same kind of process here. I did 9 over 36.25 equals 1.25 over x. Cross multiply, 9x equals 45.3, so x is 5.03. Okay, this is the end of 7.2.